I'm going to go ahead and start and hope that this catches up and then that I can change slides at some point. My name is Tinghitella, and today I have the opportunity to share with you some really recent data coming out of my lab in which we are looking at the possible evolution of a new and novel sexual signal in this Pacific field cricket, Tinghitella oceanicus. And I'm not allowed to change slides, so we might be doing this in like interpretive dance. Yay, it worked. Okay. You guys can see what I can't see. All right, so we know that the elaborate acoustic signaling systems of crickets really do exemplify the power of sexual selection via mate choice. And male crickets produce songs that are used both in species identification and in mating interactions. They have two types of songs that are involved in mating interactions. One of those is a long-distance calling song that they project out into the environment to attract females from afar. And the second is a courtship song that they'll produce once they're in one-on-one interactions with a particular female. Songs of heterospecific crickets differ both in temporal components and in other spectral characteristics, and we know that these are the major pre-mating reproductive isolating mechanisms in a number of different groups. So the cricket that I have been working on for about the last 15 years is called Tinghitella oceanicus. This is the Pacific field cricket, and it's a really broadly distributed cricket. It's native to northern and eastern sort of coastal regions within Australia, but it's also island hopped through the Pacific to some really cool locations like Fiji and Tahiti and Samoa, and they are recently introduced to the Hawaiian Islands. And there's been quite a lot of work done on Tinghitella in the Hawaiian Islands recently because there is a novel natural enemy that these crickets encounter only in that portion of their range. And this is a parasitoid fly that is attracted to the song that male crickets produce to locate females. So typically when a male cricket starts to call, he's doing that from a fairly stationary location. He'll produce this long distance calling song that's projected out into the environment. Females are the locomotory sex, so they'll move through the environment in search of the male who is producing that song. In Hawaii, however, when males call to attract females, they also risk attracting this deadly parasitoid fly called Ormia ocracea. Gravid female flies are attracted to that very same signal that male field crickets are producing. They'll locate a singing male and sort of spray larvae on and around that signaling male. Some of those will burrow into the body cavity of the cricket, where they'll spend the next 7 to 10 days feeding on abdominal and thoracic tissue before they finally pupate, emerging and killing their cricket hosts in the process. To produce these sort of deadly songs, males are using specialized structures on the forewings, and the most important for our purposes today are the file and the scrapers. The file is this modified wing vein that has a number of evenly spaced out little teeth on it, and when that file from one wing comes into contact with a scraper or a hardened region on the second wing, you get pulses of sound with each wing closing motion. There are also a series of resonating structures, things like the harp and the mirror, that project the sound that the cricket is producing. Okay. Resume slideshow.
Oh no.
That one. We're really going to do this in interpretive dance. It's going to be It's not even responding now. Okay, we can just jump to the good stuff. That'll be great. We'll do this. All right, well, what were we talking about? Whatever. So they've got these structures, they make sound with them, it's all great. As a graduate student, I was really lucky to be part of a team that stumbled into a new type of cricket, a new morph in the Hawaiian Islands, and we call these flat-wing crickets. You've probably heard of those ones. These are crickets that are missing all of the structures on their wings that are used to produce sound. And so they're obligately mute. They're completely incapable of producing that sexual signal that males are so well known for. And despite that inability to call, this mutation to flatwing morphology spread through the population in fewer than 20 generations, from negligible to more than 90% of males in that population. So for about the last 15 years, that was sort of the status of really cool rapid evolutionary change in crickets in the Hawaiian Islands. And that is until about 2 years ago when I went to Kalapapa National Historical Site on the island of Molokai for a completely different reason. I was there working on anthropogenic noise, and I didn't know if there were crickets there. I wasn't particularly hopeful. So I went into this national park for a single night, and I took with me a single Tupperware container, because I'm a really awesome field biologist. And that's where I was going to collect all of my crickets if I happened to find them. I hunted around for about an hour and didn't find anything until I stumbled across this one field at a place called the Bishop House. And I was super happy to find that there was this very happy little population of Teleogrillis living on the lawn at that one particular house. So I took 45 of these I collected in about an hour. I threw them all into my Tupperware container, and I took them back to my room with me, where I hoped that females would lay some eggs for me that night so that I could take them back and establish a colony. And while I was in, I got excited. So while I was in my room, about a half hour later, I hear this cat purring in my room. And I thought, well, that's a little weird, but it isn't that weird. We often have cats at our field sites in Hawaii. The really weird part, though, is that this cat was purring from the inside of my cricket container. So that was a little, kind of cognitive dissonance situation. So I took a look at what was going on, and it turned out that they were actually crickets. So there were crickets in this container that were producing a sound that was reminiscent of a cat purring, but that had the same sort of temporal characteristics as the typical cricket song that's produced in this species. So I was able to identify that this was indeed Teleogrillis, but they were producing a sound that had a lot of different spectral characteristics that were completely different from that initial, from that typical song. So what I would have played for you was a typical calling song, a typical courtship song, and then a purring calling song and a purring courtship song. And the major take-home messages from those different songs are that indeed the temporal components of the song don't seem to differ between these different types, but other spectral characteristics of that song really do differ. So our songs differ in how broadband they are, the amplitude of the song is dramatically different, and the frequency, the pitch of the song is incredibly different. And that's what I wanted to focus on for part of the show that I was going to give you today. So one of those major take-home messages is that the median peak frequency of our typical song is about 4.9 kilohertz. That's also the peak in hearing ability, both for female crickets and for female flies. And the median peak frequency of the purring song is 10.2 kilohertz, so dramatically different from our typical ancestral song. What I find really super cool about this, though, isn't just that there's a difference in the frequency or peak of these two different songs, but that there's a huge amount of variation in the peak frequency of purring songs that you just don't find in the peak frequency of the typical songs. So tons of variation that seems to have somehow been released in this new potential sexual signal. Yeah, but it's kind of not worth it at this point. I'll just wing it. Sorry to the next people who might have to deal with this too. All right, so peak frequency. So we're really interested in that variation. My next question as a person who studies sexual selection was, does this actually matter at all? Is this a signal of any kind, or is it just a noise that's being produced by some different thing on the wings? Well, it turns out that the morphology of our typical crickets and our purring crickets is pretty dramatically different also. So it turns out that silent crickets, those ones that are flat wing, they're missing all of those structures on the wings that are used to produce that typical song. Purring crickets actually have intermediate wing morphology between the typical and the silent. So they have a reduced phylum scraper mechanism. They have a reduced harp. They sometimes have a mirror. They do have a scraper, and it's that difference in wing morphology that we think is responsible for all of these different sort of characteristics that are dramatically changed between our ancestral and our current type. So does it matter at all? We used phototaxis trials or mate location trials in which we released a female in the center of an arena and gave her the option of either approaching a speaker that was playing a purring song or 3 speakers that were playing absolutely nothing. And we were interested in which speaker the female would essentially bump into first. And we reasoned that if a purring song was no better than silence at attracting females, that the female should then bump into a purring speaker 1 out of 4 times, so 25% of the time, and a silent speaker 75% of the time. And what we found was actually the opposite of that. So we found that females were much more likely to encounter a speaker that was broadcasting a purring song than they were a silent speaker, which suggests that indeed they can hear it and they're interested in it. So 60% of females successfully found that simulated purring male when we did this experiment. The purring song isn't as good as the typical song at attracting females, so it takes females longer to get moving toward a purring song than it does a typical song. And once they get moving, it takes them longer to locate the source of a purring song than it does a typical song. So why are we so excited about this, right? So like, why does this matter? Why should we care? Well, we are really interested in this as the potential origin of a novel sexual signal. And we're interested in that because we know that sexual signals are often the most divergent or the only divergent traits between closely related species, and that strongly implicates sexual selection in speciation somehow. And the origins of new sexual signals have only actually been observed once before. There's a jewel lost story. It's a very cool story about a new pheromone. And one of the things that I was going to highlight is that we don't know on Molokai when this new trait arose or arrived, because we didn't work on Molokai before finding purring crickets. But I have worked on these neighboring islands within Hawaii for the last 15 years, and we have no evidence from my lab, from any of the other labs that work on this particular set of populations, or from the literature that there were purring crickets in any of those other locations prior to the last handful of years. But we now find purring crickets on 4 different islands in 5 different replicate populations. So we've got 5 replicate places where we can go to look for typical purring and silent crickets, and we find them in different ratios and different combinations across these populations. And we know that in some of those locations, purring really is a new and novel trait. So we're interested then in understanding what are the sort of time zero selection pressures on this potentially new signal. So are flies paying attention to this thing? Are female crickets paying attention to this thing in the field? So we've done a little bit of work on that over the last couple of years. We do find that the parasitoid fly is in all of these locations. And in about 50 phonotaxis trials with flies, we've been able to show that about 50% of them do positively respond to some variant of this purring song. So perhaps purring is under the same conflicting selection pressures that the ancestral typical song was under. And one of the things that we've been spending a lot of our time thinking about recently is sort of time zero preferences. What do females think about different variants of this purring song? There's all of this variation that I told you about earlier. What do they think about that? So with the help of our